All right, real quick, just over here. The last time we meet for this class at 8:30 is Thursday. So that's when this class is done. We don't meet next week. Next week it'll just be an office hour on Tuesday from 7:30 to 9:30 before your final at 10. Okay. So if you don't want to be here next Tuesday and you just going to show up with the final, just show up with the final. But we won't meet because we don't take a final. All right. So next Tuesday, you'll have to be there for the class. Or we'll have to send finals. Or send the finals. After you email your fine. It's not good.
So like, and still trying to keep companies message.
Okay.
So
That's why that. So over here. These are all the problems we've already done. These are the extra problems that are on that YouTube link that I posted in the announcements and I actually sent to the email. So that's homework wise. Actually, I forgot to put 3.3 up here, I think. Yeah. It's 3.3 as well. There was a lot of examples on 3.3. Seventeen, 24, 26, and 27. I also want to point out, you are always more than welcome. You're always more than welcome to cook. If you want to come to Monday and Wednesdays co-rec, if you want to show up tomorrow and be in their co-rec and get an extra day of review because that's what they're going to do tomorrow, that's fine. If you want to show up, well, next week is just office hours, so that's fine. On Friday, Zoom, but next week it's off, so we don't meet for class. So next week, Monday and Tuesday before the final, no class, but office hour from 7:30 to 9:30. So for the final. And so if you want to be here, you can. If you don't need to, then you don't need to. But I get you yours, right? The quiz? Okay. Calculus that. And then computers. Yes, no, we're just going to the next, we'll just see that. So, let's say, basic class equal to the sign, so that's just the class. Yeah. And so here. It's like, I don't know how we've been learning, 2 times 5 is 6. So that's just 5 over. 3 is supposed to be 2 times 5, so 5 is a 2. So I don't see that right there. So it looks like it's a 5 and 3. The 3 goes into 6. So if somehow you got a 10, you went from a 5 to a 10. So you change. So it's like everything was going great. So this is what it is. Okay. And Monica.
Yes.
Anybody else just walk in? Monica, Jen. So like I said, all in all, pretty good quizzes. So, what do you want to see? Yes.
I mean, like your homework.
Anything that we've done is already on the board. But yeah, if you want to see something again, we can do that. You ask, and I will deliver. I can. 9714. Like I missed 97, it goes 94, I have 96, 98, 102, 97.
I'm so sorry.
All right. So, you're going to kick yourself, that's all right.
I have to lead you home and get my.
Dog is usually fast asleep at midnight. And when I finally can feel like I can fall asleep at around 2:30, I crawl in bed, I'm under the covers, and then I start hearing this. I ignore her. And then she keeps going. The next thing, I said a little bit louder, so I kind of roll over and I look, and she's just sitting right over my head, and staring at me. Not just, And it's like, okay, troubles, what? And it's like, really? You want to go out now? You want to go outside now? I just was starting to go to sleep. Fine. And every night. It's like, that's the trigger. My going to sleep is what she wants to do. All right, right here. Rules of logarithms. Rule number 3. And again, the what rule it is, what number of rule it is, really doesn't matter. But you want to recognize when the base of the logarithm is the same as the base of what's inside. Log base b of b to the x. Base of the logarithm is b, and you're taking the logarithm base b of something to a power. Logarithm base b undoes exponential function base b. That's their role. They undo each other. So the answer is just that x. So when you have natural logarithm, which is a base base e logarithm, natural log, and then inside you have an e to the x. So this logarithm is base e, and inside you have an exponent that is base e. They undo each other, just get the same. So this is just 3 minus 7.
Okay, so I feel silly. I actually wrote that down and I got that one. I'm in 50. I'm sorry. I'm looking at the board and I'm going, that is the easiest question. I know that. I practiced that one.
And so, yeah, but that's a good question in terms of if you see something like that in tomorrow or Thursday's test, you got to jump on that one. You might want to go through the test while you're still wide awake and look for those. You know, get all the ones right that you definitely can get, and then go back and them, see the ones that you want to spend more time on. Maybe you say the division ones, the first few problems, but those until you finish all the easy ones, or not so much easy ones, but the ones you know you can get. Nice. So 59?
Yeah, I'm sorry.
So now the good news is that it's going to be multiple choice of kind of a question. You guys that are coming in, I'm already getting you as here. So don't worry about telling me that I'll give you your quizzes back at 10. $59. We have the cube root, the cube root, big cube root, or it's like, copy it down. The natural log of cube root x to the 4th over y to the 3rd. David? No, David? Root of exponents. Some difference in power properties. So start to see a couple of things. Number one, we have a fraction. We know we can separate fractions with subtraction. That's right here. Number two, log base b of u over b, we subtract the log. Natural log, we still subtract. Natural log of the numerator minus the natural log of the denominator. But we have a cube root around the whole thing. None of these have a cube root. Okay? have a cube root. There's no radicals in any of these. So we have to be able to change a cube root into an exponent. That's where the rules of exponents come in. Number 9. Over here, number 9 says a to the 1 over n is equal to the nth root of a. So if I have an nth root, I can change it to a fraction. So if I have over here a cube root of a, that means it's a to the 1/3 power. Logarithms undo exponents. So you can't leave it as a radical, you need to change it to a power, an exponent. So this is going to be the natural log. Now that cube root is around the entire fraction. So it's around the x to the 4th, y to the 3rd. That whole thing is a 1/3 power. Okay, so we're still not ready to separate. We're not ready to separate because the rule says natural log of u over v is equal to the natural log of u minus the natural log of v. Just a separate u and a separate v. I have those in a parentheses raised to a power. So it's kind of like they're locked in this parentheses, and I can't pull them apart until I get them into individual numerator denominator. Okay? It's kind of like, so sorry for the negative analogy here. It's kind of like a divorce. Right now, they're living in the same household, but they're separating. So maybe the wife has moved upstairs, the husband moved downstairs, but they're still in that same 1/3 house. So until they really separate, really divvy up all the stuff, and before they can split apart, we have to still do the rules of exponents, because now this rule comes in. Rule number 4. A quotient to an exponent. And this is where I hate to use the word beauty, perfection, genius, logic, completeness. But you know what? It's the rules. Math is going to give you that same answer because you just follow that rule. But it can't do it unless you know those rules. That's why everybody, no matter where you are, they're going to get to the same answer. There is no other interpretation. But we have to practice to get there. Because now it's rule number 4. A over B, a fraction like we have here, to the m power is just raise each one to that power. So this is going to be, on the rewrite, the natural log of x to the 4th is going to get raised to its own 1/3. And then in the denominator, that y to the 3rd is going to get raised to its own 1/3. They each are going to get their own 1/3 power before the breakup, before the split. And then it becomes rule number 2. Rule number 2 says when you have a power to a power, a to the m, when you raise it to the power of n, you just multiply the exponents. So before we do any more, we're going to just do, this is the natural log to the x times 4 times 1/3 over
y to the 3 times 1/3. And you gotta be careful, gotta be comfortable with your fractions. And for some reason, I'll blame Bubbles because Bubbles didn't let me sleep last night, so my handwriting is all kind of extra long. And so, x to the 4 times a 1/3, it's multiplication, and then y to the 3 times. But I reverted to my 3rd grade handwriting. Never a straight A student because the handwriting, great.
So you were some you were having trouble when before you put it into the calculator. You had to show me that step where you had to simplify the fraction and show that e to the what power, because I had to put in fractions. You had to show that simplified fraction before you put it in. And that simplifying fractions, that's what this was getting.
4 times 1/3. It's not 4 times 1 and 4 times 3. This is 4 over 1 times 1 over 3. And when you multiply fractions, you go straight across. You don't need a common denominator. You just multiply 4 and times 1/3, 4 over 3. You have 4 times 1/3,
Well, you have 4/3 of something. So 4/3, 1/3 plus 1/3 plus 1/3 plus 1/3 is 4 of those thirds. Okay, so 4/3.
So this is the natural log of x to the 4/3 over, now here's what's nice. 3 times 1/3 is just 1, because that's 3 over 3. So that's just a y. And again, this looks horrible because it looks like it's the natural log of x to the 4/3 and then something over y, like the whole thing's over y. How you write and what you expect to be seen, you have x to the 4 over 3 all over inside the logarithm, y to the first.
We're 2 steps away from the final answer. So we've done 1 step, 2 steps, 3 steps.
Now that we have individual numerator denominator, it's the natural log of the numerator, x to the 4 over 3, minus the natural log of the denominator, y. And there's one last thing you can do, which is the Price is Right rule.
You wouldn't leave x to the 4/3.
You would bring it down in front, come on down, and you get 4/3 times the natural log of x minus the natural log of y.
Now, even though your test question is multiple choice, I would not give you one this ugly. First of all, I don't want you to have to think you have to work it out, because some people are going to try to work it out. When we go to the review sheet, I want you to see it as something you don't necessarily have to work out. It's process of elimination, really.
Y to the 3rd times 1/3, even though it equals out to 3, wouldn't it be y to the power of 3 still? No.
No, because it would be
3 times 1/3 is 3 over 3.
Oh, then it equals 1, okay.
if I have 3/3 or something,
Yeah.
I get a 1. But when I play 4 quarters of football, I play the whole game, 1 whole game.
So that is a really good example of an extreme problem. All right, so here's some. Myra, you're here. Angel's here. Jose? Anissa?
Right.
But it's all the stuff, all those rules coming together in one question. If I gave like, all right, here's a final, it's one problem. That covers a lot from the entire semester. Not multiple choice. You gotta like show every single time step. If you're having to do this kind of a question, you know what? I would say you would need to go from here to here, but you could go from here to here and to here. So you could skip this one and you could skip that one. You could go just to that. So 1, 2, 2, 3, 4 right there. What else? Just tell me where it's from and what you want to see. And if you just got here, those are the things we've already done. The green is from the extra YouTubes that I posted. And don't forget, this Thursday is the last time we meet for this class. We don't meet. Next Tuesday, we don't have class, but it's an extended office hour. Next Monday and Tuesday, office hour from 7:30 until 9:30. The final starts at 10. And you're always more than welcome to show up tomorrow if you want to come to tomorrow's co-rec. And go and ask questions from that. And you can ask questions from anything. If you want to go ask questions from the final focus, that's fine. Either today, that's why it's up there, or on Thursday. And I did not make copies of the final focus, so it's posted. Oh, yeah. There's a 16-page and a 32-page version of the same thing. So if you want to print it out, I print out. Oh, yeah. Yeah, double page 16. 32, 16. Point form the review.
We do any of the synthetic division.
You got to tell me which number. 24 on the review? Yeah, 24?
Yes.
And at 10 o'clock, I will tell you how the review sheet matches up with the actual test. Okay, we're going to write this in the logarithmic form. Actually,
So we have 11 over 3 to the fourth power, and that's equal to 14,641 all over 81. So if I raise this to the fourth power, 11 to the fourth is 14,641. 3 to the fourth is 81. We're supposed to rewrite this in log form. So somebody took our log
of X and equals some other thing Y.
Somebody took our log base something of something equal to something, and then base to the across equals what's inside. They took this apart and ended up with this. So now we want to put it back in the log form. Base to the across equals what's inside. So what's the base of this log? 11/3. The base of the logarithm, same as the base of the exponent. Base is base. If anybody starts singing that song, I'm gonna. So it's a subscript. It needs to be legible, but it needs to be down here like that. Log base 11/3. This is notation. It cannot be what you want to write. What you want to write needs to be the right thing. Okay, but I write it this big anyway. Okay, good for you, it's wrong. But I still, the name Jim, G-Y-M. Good for you. That's not my name. Okay. It would be cool if that was my name. Maybe I could be like, I don't know, somebody on TikTok. But it's got to be written like this. Don't lose points just because you're not being careful. So log base 11/3, base to the across equals what's inside. So where's the 4 going to go? Inside or across? It's going to be over here. Base 11/3 to the 4th equals what's inside. What's inside is this 14,641 over 81. Log base 11/3 of 14,641 over 81 is equal to 4. I would not give you that on Thursday because I wouldn't want you. Oh, that's setting you up, well, not you. I'm not saying I'm pointing at you, but that's setting up a student to fail because I know the handwriting is not going to be precise. But when you are given this one, e to the 5.8 equals x. If the base is e, you have to use natural log notation, LN notation. I know it is log base e, base to the across equals what inside. So log base e of x equals 5.8. That is technically correct. But when it's base e, natural log notation, natural log x equals 5.8. What do you prefer? It has to be natural log notation. If it's base 10, I'm not going to take off points if you don't put comma. If this was a base 10 and you put log base 10, that's fine. But technically, when it's log base 10, we don't put. That's the only one you don't have to see a base. 24. Did you find one, Myra?
Yeah, can we finish 5?
Or 5? Now, and I'll go over this on 10, but in terms of synthetic division and long division, it is going to look like this on the test. This is the mock-up. You have 2 long division problems and 2 synthetic division problems. The first long division, you don't have to worry about doing anything to it. It's going to be ready to go. In other words, it's going to be nice. The second long division, you might have to rearrange it, or you might need a placeholder, but it's not going to have both. You might have to rearrange it, put it in the correct order, or you might need a placeholder, but not both. And then same thing with synthetic. Synthetic is ready to go. But then the second problem, you might need a placeholder or you might need to rearrange it. Okay? this one. X to the fifth plus x to the third plus 1 over x plus 3. First thing I would do I need to rearrange it? No, it's in decreasing degree. 5, 3, and x to the 3. But I need placeholders, so we're missing some powers. So I would do that first. I don't want to do that when I'm trying to write out the synthetic set. I would want to write it out here. So this is missing an x to the 4th. So I need this way. So I have my x to the 5th. I need an x to the 4th, so I need 0x to the 4th plus 0x to the 4th. And then I have 1x to the 3rd, so plus x to the 3rd. I'm missing x squared, so I need a 0x squared. And I'm missing an x to the 1st, but I need a 0x. And then this is my constant, plus 1. So it was missing 3 terms. So I needed 3 placeholders divided by x plus 2. So now we're ready to do the division. So first thing, to make sure you figure out what k is. We're dividing by something that looks like an x minus k. X built-in negative minus a k. So if I see positive, what's this k value going to be? A negative 3, k out the opposite. So we set it up this way. We draw that box. We put k in the box, k is a negative 3. And then we list the coefficients of the dividend. So my coefficient, this coefficient is a 1. 1 times x to the 5th. And then we have a 0, x to the 4th. And then we have a 1x to the 3rd. And then we have a 0x squared. And then we have a 0x. And then we have one last term, a 1. 1, 0, 1, 0, 0, 1. Okay? And then we draw a line. Now we're ready to do the synthetic division. All of that is just a setup. Synthetic division for here, for this problem, is less time than it is for the setup. So the first thing you do, you bring down the first term, the first coefficient, bring down the 1. Then we multiply times the box, 1 times that negative 3. You get negative 3. And then you add that first that placeholder plus this negative 3 is negative 3. And then you multiply again. So negative 3 times this negative 3. And you get positive 9. And then we add 1 plus 9 is 10. And then you multiply 10 times negative 3 is negative 30. And then you add 0 plus negative 30 is negative 30. And then you multiply negative 30 times negative 3. And that's positive 90. And then you add 0 plus 90 is 90. And then you multiply 90 times negative 3 is negative, I'll actually write it, 90 times negative 3 is negative 270. And then we add 1 plus negative 270 is negative 269. The last term is the remainder. Everything else is a coefficient for the quotient. We were taking x to the fifth and we were dividing by x to the first. So what will the first power be of my answer? What will be this exponent?
X.
X to the fourth. X to the first goes into x to the fifth leaving fourth. So this is going to be one time, and this will be, you'll lose a point if you leave it. So I'm just going to show you, it's 1 times x to the fourth, and then we just go from 4 down to the 90, minus 3 times x to the third, plus 10 times x to the second, minus 30 times x to the first, plus 90, and then you have plus negative 269 over the original divisor of x plus 3. You have to have a plus the remainder over the divisor. Now, simplify. 1 times x to the fourth. That would lose a point because that's not simplified. 1 times x to the fourth is just x to the fourth. So don't leave that 1 times it. If you need to write it, because what do I do with this 1? It's right here. 1 times x to the fourth. Without the 1, you wouldn't have an x to the fourth. That's how you do the synthetic division of something that messy. What would you, where would you see something with that many terms? The bonus question, you have 1 long division, 1 synthetic division as bonus questions. On those, it will be, you'll need to rearrange it and have placeholders. But I'm not going to give you an x to the fifth as a test question. Showing me something with an x to the third, I'm sure you can do an x to the fifth. If all you're going to do is put a placeholder or rearrange it. So I'm not going to make you do 5 minutes of work when you have the rest of the testing. And that will just stress you out. A lot of times you just look at it and go, I'm out. I'm going to try. Walk away. But if it's an x to the third, okay. What else?
Number 3.
Number 3. For synthetic is addition. Long division, just like when you first were going through it, you subtract. Long division, subtraction. And what really is happening is the subtraction is happening because we do the opposite sign. Or when we multiply, when we take out the k, we have that positive 3, we took out negative 3. So the subtraction is actually happening. Yeah. That way you don't have to worry about doing the subtraction every single time and worry about changing signs. That you have a negative minus a negative. So number 3, 5x to the fifth minus x to the third minus 4x squared minus 235 times x plus 28 divided by x squared minus 7. And that is long division. Because it cannot be a synthetic division. This one you would not be allowed to do synthetic division. Why? Because of the x squared in the divisor. Synthetic division can only be used if you're dividing by something that looks like x minus k, which means it's 1 times an x to the first. You can only divide by something that looks like x minus k. So x 1 times an x to the first. So dividing by an x squared is out of the question when you have synthetic fluid. Okay? And keep an eye on the screen. Yesterday was pretty good. It didn't go blurry on us. But sometimes I get not so much distracted, I get absent-minded in my declining years. 5, 3, 2, 1 constant. So we're missing a power of 4. So we need a placeholder. 5x to the 5th plus 0x to the 4th. And then minus 4x or minus 1x to the 3rd, minus 4x squared, minus 235x plus 28. And we're dividing by. This has to be in the right order and have all of the power. So this one's missing x to the 1st. This one needs a placeholder as well. X squared, we're missing x to the 1st, so 0x. If you don't have the placeholders, things won't line up in the right place value or in the right columns. So dividend and divisor have to have all their powers, from the highest power down to the constant. Now we're going to do the long division. The divisor is over here on the outside. Dividend goes inside. OCP taking away. It doesn't get confused with everything else I'm doing. I'm going to get that out of it. When we do long division, the only thing you look at, the only thing we care about is this first term, x squared, and this first term, 5x to the 5th. And you're going to make a choice on the quotient. What times this x squared, something times that x squared, is supposed to give us, is supposed to give us a 5x to the 5th. I need a 5x to the 5th. So what I'm going to multiply by, it needs a 5. I need a 5 times that. So I have an x squared, I want x to the 5th. So how many x's do I need here?
3.
And x to the 3rd. 5x to the 3rd times x squared would give me 5x to the 5th. So this is what I'm going to use as my first term. Let's go through it real quick. You have choices. You can start with this column, which is x to the 5th. If I choose to start with an x to the 5th times this x to the 2nd, I'm going to get x to the 7th power. I don't have an x to the 7th. So you don't want to start with this column. You could start with x to the 4th times an x to the 2nd. That's an x to the 6th. We don't have an x to the 6th. So you don't want to start above this column. This would be your next choice, because you're going to go this way with your quotient. So you're going to start with x to the third, 5x to the third should go here. Now you have, at the most, 3 more terms. At the most. Once you make that choice, just like long division, you now multiply times the divisor. But this time, your divisor is a polynomial. So if you have to, do it on the side. It's 5x to the third times this whole x squared plus 0x minus 7. And this is where the placeholder comes in. It does its job. 5x to the third times x squared is 5x to the fifth. 5x to the third times 0x is 0x to the fourth. 5 times 0 is 0. And then 5x to the third times negative 7 is negative 35x to the third. So we get 5x to the fifth plus 0x to the fourth minus 35x to the third. And that way, all the power line up. They're in the right column. And the next step, you subtract. Subtract each one. This better cancel out, and sure enough, 5x to the fifth minus 5x to the fifth is 0. And look what happens here. 0x to the fourth minus 0x to the fourth. No more x to the fourth. So we don't have anything in the x to the fourth column either. Right here, when you subtract the negative, that becomes plus 35x to the third. Negative 1x to the third plus 35x to the third is positive 34x to the third. Minus 4x squared minus 235x plus 28. And then we go again. This time, we're going to make this x squared equal to this 34x to the third. So the next column is the x squared column. But if I use x, well, first of all, I would need 34. Okay, that's a given. But the next column is x squared. If I use x squared times x squared, that's 34x to the fourth. I don't have anything. So guess what goes above my x squareds? A placeholder, yeah, 0. It's like if you did division, and if I try to do it in my head, I'm going to get something back. If I did 5,120, 5 divided into 5,120. And we do this. In the thousands place, how many times can 5 go into 5? 1 time. So in the thousands place, there's a 1. So I get 5,000 in the thousands place. So then we subtract. And so we get what's left over, 120. But now in the hundreds place, in the hundreds, how many times can 5 go into a 1?
No.
It can't. So you have a placeholder because 5 can't go into that 1. There has to be 0 times into that 1. So now you're in the tens place and you're looking at 12. How many times can 5 go into 12? 2 times. So 2 times 5 is 10. And then you subtract, and that's 20 left over. And then in the ones place, how many times can 5 go into 20? 4 times. 4 times 5, 20. But when it had that 1, it doesn't go into, one won't, so there's a placeholder. So right here, we have a placeholder where the x squareds are. 0x². And that at least helps us know that we have to go to the x to the first. If you don't put it, that's fine. Just as long as your next choice, you're probably going to see you need an x to the first to make an x to the third. You'll probably come up with that, 34 x to the third, which is what you want. But just don't put that answer plus 34x above the x squareds. It's not necessarily wrong if you wrote it that way, but it might mess up your thinking because it's lining up in the wrong way. That's what messes up long division, where everything goes wrong in arithmetic for kids is based on little brothers and sisters, kids of your own. That's what messes them up, is handwriting and lining things up. You see their long division, they start to go like this. And everything starts to trail out that way. Okay? So we have 0x², and then we're going to use 34x. So we have to distribute. Thirty-four x times x² plus 0 is minus 7. That gives us the 34x to the third. We have plus 34x², and that's going to be minus 238x. No, son. What did I just mess up with? I'm going to have a big boo-boo. Major boo-boo. Maybe even a major yogi and a boo-boo. I guess that'd be a ranger yogi and a boo-boo.
Ready for next one?
Yeah, and what should it be? Yeah, 34x times 0x. I'm getting way ahead of myself. Slow down. I gotta catch that. So that should have been 0x. Yeah, we took that. Better be 0, cancel that. Negative 4x² minus 0x² is just negative 4x². 235x minus a negative, so that becomes plus. Negative 235x plus 238x is plus 3x, and then a plus 100. So now we want 4x². So what times this x² going to equal 4x²? Just a 4. We're going to multiply by 4. Okay. You don't have to do it on the side. If you see it, I want 4x², so I'm going to multiply by plus 4. And if you just want to distribute, I mean, this is a big problem. 4 times x², you're going to get 4x². That's fine. Again, I'm not going to give you an x to the 5th. 4x². And that'll be 40. No, it's going to be 0x. And then minus 28. 4. See, I wrote it down wrong. I didn't want to make 4x squared. I wanted negative 4x squared. All those little things. So I'm not going to use positive 4. I need to multiply by negative 4. So if it's negative, the signs are different. Bubbles as they get the daddy comes home tree. She just doesn't want like one little kibble. I have to sprinkle kibble. To use a phrase, it better rain. The rain of the kibble. That has to be 0, because if I didn't do it before, it wouldn't have been 0. That's why I saw that there was a mistake. When this was positive and I didn't fix it, when I subtract, that's now negative 8x squared. So it didn't cancel out. That's why I knew. So when we change it to the negative and we subtract, that becomes a positive. Now it's a 0. 3x plus 0x is 3x. 28 minus 28, that's a 0. So we have a 3x. And then we see, all right, 3x. There's no way x squared is going to come up with an x to the first. Also, we're at the end. This is the constant. We have no more terms to go. 3x is the remainder plus 3x over x squared minus 7. Now, you don't need this as part of your answer. Simplify. 5x squared plus 34x minus 4 plus 3x over x squared. Let's see if I can get a nap in before 10 o'clock.
Why would it be 5x squared if there's
Square cube.
Yeah.
Because I need a nap in before 10 o'clock. When I taught at Buchanan, there was like a break from 9:45 to 10. I would go in the math office and actually take like a 7-minute nap. Well, you'd be surprised how much a 7-minute nap can have. Anybody else come in from the co-rec? Right. I'll give you your quizzes back at 10. I'll do more.